something like this, like 47. 47 on page 731. In this problem, sine squared x, cosine squared x, we're asked to present it in terms, and it's a very important issue, and why? Why? It's getting you ready for integration. So we don't talk about integration in this class, and we talk about integration in, a lot in Calc 1, but not about this, because this is in Calc 2. So the reason why we want to change this product into only cosine, it can be cosine of 5x, it can be cosine of 3x, it can be 2 cosine, but no powers, no powers. We just want it for integration. So we want to replace sine and cosine, this product of sine of cosine. What do we know about this? And what do we know about this? We just looked at the formula for the half angle. So what did we write about sine squared? What was sine squared equal to? 5 minutes ago. Can anyone dictate for us? 1 minus twice x, very good. 1 minus cosine twice x over. And the other one is the same, we go with plus. So this one changes into 1 minus cosine x over 2, and this one changes into 1 plus cosine x over 2. So we don't want any powers, and we only want cosine. Okay, but this is not done. Because once I distribute, I'm going to get another power for cosine. So it's not done. I recommend taking 1/4 outside. And then multiplying these two, it's a minus b times a plus b. So this is 1 minus cosine squared x. Now I have a different situation. Oh, I forgot to write 2x. Sorry. I said something is not right. Okay. So now it's good to have cosine 2x, but we don't want the power on cosine 2x. So we change sine squared into 1 minus cosine 2x over 2. We change cosine squared into the same thing but plus. We multiplied 1/2 by 1/2 and we got this. We multiplied 1 minus cosine twice x by 1 plus cosine twice x and we got this. But now I have a problem because I have a power. Cosine 2x is fine, but it has a power. So I have to apply the same rule one more time. Or the same identity. So how will this look like? 1/4, 1 minus. Can anyone give us the same identity we used for cosine squared? But this time is for cosine squared, cosine 2x squared. Can anyone give it a shot? 1 plus, because it's cosine. Cosine of. Okay, let's go back. If this is x, this must be 2x. If this is 2x, this must be divided by 2. So this is the reduction formula. So we are reducing a product with powers into simple cosine, only cosine with no power. It serves a purpose, but not in this class. A very good purpose. So 2 minus 1 minus cosine 4x divided by 2. So at the end, this is 8, and this is 1 minus cosine 4x. So this is a huge achievement for what follows. But right now, remember we started with the product of 2 functions, sine and cosine. We changed the whole thing into only one function, just cosine, with no power. Again, I cannot show you where this is going because you have to get to Calc 2. You're going to see this a lot. So this is what we call reduction formulas or reduction process. Now, this is a simple situation, but if we have a situation like this, let's say sine to the 4th times cosine squared, in order to reduce this product to simple cosine with no power, it takes a much longer process. It takes, first of all, I have this, which is sine squared times cosine squared
Then I have sine squared, which is 1 minus cosine 2x over 2, everything squared. I have 1 plus cosine 2x over 2. I have to square this, distribute, I just wanted to write etc, 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 etc.
So that's a much longer process. Because I have to square, I have to distribute, and I have to apply the same formulas several times. Which formulas? These ones. Sine squared of x equals this, or sine squared of 4x equals 1 minus cosine 8x over 2, and so on and so forth.
So I chose a simple situation in which we only had sine squared times cosine squared. But it's a lot of work with those reduction formulas. Let's prove an identity. Any questions? Would you like to go back and practice any of this? Is there anything that you would like to go back to?
Yeah, I got lost after
Which one?
double angles.
Which one will you go back to? Which one?
Can we do another reduction?
Yes. Yes.
Uh,
Yes.
Can you please clarify the step? It's 1 minus,
The previous problem?
yeah,
This one?
yes.
Perfect. Yes.
So after this step, 1 minus cos squared 2x.
Yes, this one?
No, next.
Here?
Yep.
A minus b times a plus b is a squared minus b squared.
No, sorry, it's the next one.
Yes?
1 plus cos.
So I copy 1, I copy -1, so now this
Yep.
is cosine squared, right, like we had it here. Cosine squared x is 1 plus cosine twice x. Cosine squared twice x is 1 plus cosine 4x over 2. It's the same formula,
Oh,
but this time for twice x.
got it.
Better?
Yep.
And then we find the least common denominator, then we multiply by 1/4.
Okay, so we want another reduction formula. Would you like to continue with this? We can, or we can find, or I can come up with an easier one.
Can we do a different one? Just to like get
Do you want to continue with this one?
a different one?
A different one, okay? Very good. What about cosine to the 4th x?
We want to change this into an expression only with cosine, and the cosine can be of any angle on the planet, but it has to have power 1.
Power 1. Okay, so what we have to start with is the 1 plus cosine twice x over 2 everything squared. Because this is cosine squared x everything squared, and cosine squared x is 1 plus cosine 2x over 2.
Is this okay so far? So since it's cosine to the 4th, cosine to the 4th is cosine squared squared. I don't have a formula for that, but I have a formula for this, but I just replaced it with 1 plus cosine twice x over 2. But now I have to square that.
So when I square this, I get 3 terms at the top and 4 in the denominator. First term squared plus 2 times the first times the second plus the second term squared.
Tell me to find the point where you want me to go back to. Okay?
So once we have this, this is okay, all the numbers are okay, but this is not okay because it has a power. So 1/4 outside, 1 plus 2 cosine 2x plus. Can anyone tell us what we should replace this by?
We had it 5 minutes ago. Cosine squared of twice x.
Cosine
1 plus, it has to be a fraction with 2 in the denominator.
1 plus cosine 4x.
Excellent. That's it.
So this is indeed 1 plus cosine 4x divided by 2.
And now we are kind of done. Kind of. I have to rearrange, I have to eliminate the denominator, I have to put 1/8 in front, and then simplify in parentheses a little bit. This is it.
So this will be 1/4. The least common denominator is 2. So 2 plus 4 cosine twice x plus 1 plus cosine 4x. So this is 1/8 in parentheses. 3 plus 4 cosine twice x plus cosine 4x.
Okay, what have we achieved? Here we changed cosine to the 4th power into simple cosines with power 1. Again, what's the purpose? We could not integrate that one, but we can very easily integrate this one. But it has no application right now for us, other than the process that we just went through.
I would like us to look at an identity.
It says, for the following exercises, prove the identities. What about 58?
Is that okay? 58? So again, remember, we have to decide where to start. 58, page 731. So we have sine squared x minus 1 squared equals cosine 2x plus sine to the 4th x.
Honestly, I have no idea what to do. Potentially I should start over there, maybe factor, I don't know. Potentially I should start over here, I have no idea. Maybe this one is better because I have to square, and I kind of see how to get there. By squaring this, I'll have a sine to the 4th. So I think I'm gonna start here on the left. Sometimes we may have to simplify both. This time, in this problem,
I think I'm going to start on the left-hand side. And I'm going to square this as sine to the 4th x minus 2 sine squared x and plus 1.
okay, so it's kind of clear already because I am allowed to peek. This is not cheating. I am allowed to peek over there. I see the sine to the 4th, and this is very clear to be that. 1 minus 2 sine squared.
It's just that it's not easy to see maybe because it's not arranged in the correct order. But sine to the 4th x plus 1 minus 2 sine squared x, this is cosine 2x that we talked about today. So sine to the 4th x plus cosine 2x is indeed the right-hand side.
It's impossible for you on any identity not to be able to come up with something,
I would say. What about one more, like let's say 61. I have no idea, again, I just picked the problem with you on 731. In 61, 1 plus cosine twice x over sine twice x minus cosine x equals 2 cosine x divided by 2 sine x minus 1. 1 plus cosine, I'm checking that I copied correctly. 1 plus cosine, yes, sine 2x minus cosine, yes, yes, yes. Okay.
Again, initially I look at this and I have no idea. But I would definitely try the left-hand side because the right-hand side, I wouldn't really know what to do to it. It's 2, it has 2 simple function cosine, simple function sine. I don't know what I would do to that. Sometimes it looks like rationalizing, we may multiply and divide by the same quantity, but right there, I don't really know what to do. So I'm going to start here on the left-hand side and see where it takes me.
So with the left-hand side again, I will change cosine to x, but maybe not before I change sine to x. Let's do that first, because this is 2 sine x cosine x minus cosine x. Of course, I will factor out what?
cos
Yes. And we have several options. We have 3 options for cosine twice x. Which one will I use? I don't know. I'm going to try the one with 1 plus 1 minus 2 sine squared x.
So we have 3 options: cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. Maybe 2 cosine squared minus 1 is better because it would cancel the 1. So if I look at, once I look at it more carefully, then maybe I should do that. Don't erase this. It's the same with 1 plus 2 cosine squared x minus 1. I will factor out cosine x, and I get 2 sine x minus 1. The numerator is now 2 cosine squared over, so it's done. We simplify cosine and we get the right hand side. So the first one was redundant, so this part was not, I didn't know initially what to do. So that is not necessary. It's not wrong, but it's not helpful here. So I better change cosine twice x into 2 cosine squared minus 1. I simplify 1 with negative 1 because they cancel out. And then I have 2 cosine squared. There is a cosine squared that now, and once you simplify, you immediately get the right hand side. Any questions? I know I have roughly about 9 minutes left. I just want to show you the sum to product formulas. You do not have to memorize those. I will give them to you on the test. Any questions on this? Any questions? Okay, so the next section is all about changing a product of cosine cosine, or sine cosine, or sine sine, and cosine sine. These are the same, basically. Sine cosine, these are. I will give you, we don't need 2 of those over there, but that's okay. So they presented them separately. That's fine. So we are changing a product into a sum. So that's one. And now we're changing a sum into a product. Again, this particular topic is not going to find applications in the next course. It's for Calc 2. Okay, but it's part of trig, so that's why. So now here we are trying to change sum of 2 sines, difference of 2 sines, difference of 2 cosines, and sum of 2 cosines in the corresponding products, back and forth. So I'm just going to put the title here. So this is page 14. This is 9.4, sum to product and product to sum formulas. No need for memorization. Okay. Let's choose anything you want. We'll look at the formula and apply it. So the following exercises, we write the product as a sum, or we write a sum or difference as a product. Evaluate the product using the difference of 2 functions. Everything is based on those formulas. I will choose first, or you will choose first. We want to start with 20? Okay. Evaluate the product using the sum or difference of 2 functions. Evaluate exactly. So let's do that. So that's 20. So 20 on 737. And we are given sine 195 degrees times cosine 15 degrees. So this is a formula that is a product. So it's a product of sine cosine. So here it is.
sine, cosine, 1/2 in front, sine of the sum of the angles, plus sine of the difference of the angles, 195 minus 15. And then we'll perform the calculations. So we are changing the sum of two functions, sine, cosine, into a sum of two sine functions, which is much easier to calculate. So this is 1/2. Sine 195 plus 15 is it 210? Very good. And plus 195 minus 15, I think, is 180. Correct? Good. How much is sine 180? How much? Excellent. Thank you. So this is 0. So all we have to determine now is sine 210. Go to the unit circle. This is exactly 30 degrees past 180. The reference angle is 30 degrees. Since the terminal side is in the third quadrant, what sign will sine have? Perfect. And how much is sine 30? So how much is 1/2 times 1/2? So then this is negative 1/2, so this is negative 1/4. This is how we apply the product to sum identity. Let's try the reverse. We still have a couple of minutes. Yes, I'd like to look at this problem, the identity 35. 35 on 737. And we have sine x plus sine 3x. They say it's 4 sine x cosine squared x. Let's start on the left-hand side. And we have sine x plus sine 3x. This is a case of a sum to be changed into a product. We have 4 identities, but this is sine plus sine, sine plus sine. So that equals 2 times sine of the sum divided by 2, x plus 3x over 2, times cosine of the difference over 2, cosine x minus 3x divided by 2. So for now we didn't do anything, just we changed the sum from a sum of two sine angles, sine functions into 2 times sine cosine according to the formula, from a sum to a product. Okay, the next step is to try to simplify. So how much is x plus 3x? How much is 4x divided by 2?
2.
Very good. How much is x minus 3x? And negative 2x divided by 2. So, but cosine negative x, we know something about it, because we know that cosine is an even function. So cosine negative x is the same with, very good. So this becomes 2 sine 2x times cosine x. It's okay to look. It's okay to look. So I see here sine, I see 4, and I see cosine squared. There is nothing I can do to this. There is nothing I can do to this. So obviously, one last step is change sine of a double angle that we looked at today into sine x cosine x. So then when we put everything together, we have 2 times 2, which is 4, sine x, and of course cosine squared. And this is indeed the right-hand side. We had 4 sine x cosine squared. This was possible